Hello, I would like to introduce you a framework which is in development now. It's called Reactive Pure Data for now. Maybe I will change the name, I don't know, because from the start it was intended for different things. So actually the framework helps you to build node interfaces, node-based interfaces. I hope you know what node is and what node-based interfaces are. So here's an example of node. It has three inputs called inlets, and it has, in this case, one output. Of course, it may have several outputs called outlets, and you may connect outlets to inlets. In this case, everything is 0, so let's change to some value and get the effect. 5 here and 10 here. You may use as many nodes as possible and connect them in different ways. So in general, this framework allows you to write the nodes like this, and a lot of different kinds of nodes. Why it's called reactive pure data? Let's start at least at first about the first word, reactive. It's of course reactive programming. Every connection you see here, every data flows between the nodes are streams, and it was the first idea that came to me. Streams are very good to connect with nodes. I'm not the first one, of course, and I see this idea in different implementations, but maybe it's the first framework like this in JavaScript, and it has even more advantages. I'll tell about them later. So it uses Kefir.js under the hood, and Kefir.js is very minimal. You see, it's 7 kilobytes library for reactive programming. And this framework is also intended to be very, very minimal. So here's the engine code, and you see it's just, wow, 534 lines for now, but its abilities are enormous. Actually, it also requires a renderer to render the nodes, I mean some output, and HTML renderer is quite large. It also uses Kefir.js here for user interactions. It's a bit larger, it's twice larger, and mostly because of different append child stuff, because also I wanted to make things very pure. And let me show you this, like the node you've seen on the screen before is like this description, and it has its renderer here. That's it. So the definitions of nodes are very minimal. I'll show you more examples. So I call these groups of nodes toolkits. Of course, a developer may add toolkits on his own, and for example, he may or she may add some input inside of the node, so it will also change the value. Actually, this input is connected to some hidden inlet. It's invisible here to update the value. In other things, it's the same, and this inlet has the default value of 1. And for example, let me move it. We send the value of 16 here. We may actually disable links. Yeah, this action is not so often, so it's hard to do this. I know. So we change the value, for example, like this, and then we enable the node that it immediately goes, enable the link, and it immediately goes here. So about the second part, pure data. At first I wanted to try to represent pure data nodes. I hope you know what it is. In short, it's a user, also the interface, but with some prepared node toolkit that allows to compose music. No, actually, the proper word is to generate music from different waves and stuff. Of course, this engine, like this RPD, Reactive Pure Data Engine, may be used for different stuff like graphics and so on. Pure data was, at least I think so, is the simplest thing to demonstrate. For sound, only for Pure Data Toolkit. It's not, this library is not required for anything else, so may not be included. I use Timber.js. It's a nice library, and it's made for programming sound in JavaScript, and it has several, actually some things look very close to pure data principles, except it has no nodes. Okay, let me demonstrate to you the pure data way. Something with sound. It's not in super perfect condition. The libraries, the framework is in development. But anyway, it's possible to do something. It's only 5 node types to demonstrate for now. So this node is the number, maybe you're common with it from pure data, maybe you know it. So we connect it as a frequency. These values are read-only, so they only may be edited. This may, actually the number may be overridden. like this. So this way we change the wave type for oscillator. We have some sound here and no sound here. Now we connect and we have some sound here and we plot it. So when we change the wave, we get the effect immediately. Now I'll try to play this sound. Probably it will be either very silent or very loud instead. Please be prepared. Sorry. I hope you hear it. And now if I will change the value of frequency, and this will overlap, it is not correct. I plan to fix this, of course. But it gives the nice effect. I hope you liked it. So let me show you these notes again. You may add as many notes as you want. There is no like smart layouting, they just appended. And of course you may drag them and connect. Sample here. Let's change this value and it changes here. So, okay. These first 5 nodes actually any node is very easy to define. They're defined as toolkits. So, for example, the number node you see here, which acts like this, is this definition. I suppose it's very simple. The only like smart logic it has is that it monitors that spinner was changed. If spinner was changed before the inlet or not. And it has every toolkit. It's the whole pure data toolkit, all the 5 nodes you've seen. It's 66 lines of code. Here you see how the sound is shown, if there is a sound or not. And they have renderers. Also, for this toolkit, it's not so much. And it's mostly append child stuff. So this is the render, HTML renderer for the number type of node. It has the spinner. It describes the default value for the hidden inlet, and it returns stream of changes. So the engine will be able to update itself. And the same check here. The renderer for oscillator is just rendering the name of a node, the name of a wave, the type of wave, and its frequency. This is very, very easy Okay, and one more feature which is commonly probably not needed at all, but if you like vertical layouts, you may change the representation. Let me show you this way, and in this way connecting things is easier, probably because they are right to left, just because of that. It's just a different design, no logic change it. And it's all CSS, nothing else. So the text's completely the same. So that's it, probably. It's the main features. Maybe I should show you the possible configurations. Or probably no, they're not important. So here it is. It works like that. You can define nodes, do whatever you want. Thank you for your attention. Bye bye.